Hi everyone, I'm Daniel and today we're going to discuss and practice test-driven development approach. The main idea of this approach is about making tests until they failed, and once they failed, we write code. We must write code until our tests passed, and once our tests passed, we should ask ourselves, is it enough? If no, then we should repeat our cycle. If it is enough, then our development is over. This approach has some benefits. First of all, our code depends on tests. It means that our tests define the behavior of our code. So for one grow-up of tests, there can be a lot of different implementations of code. For instance, lead code, where we create an algorithm that should pass tests. And we understand that implementation of algorithm can be different. The things at common that they have, it is that they are able to pass tests. And the second advantage is that our code is easy to modify. So when we make some changes, we can just run our tests and we can find our problems easily. Let's practice in Python. Oh, I have some code here. Let's remove it. 10 to 10. Okay, I'd like to create an algorithm that takes unsorted points and sort them spirally, like this. It will return a list of their indexes in initial array. To solve this, we can use two approaches. We can use matrix way to move in this direction, or we can use angles. We're going to use angles. Actually, first we should find a pivot point. So there is no code, and here there is some code. First of all, I'd like to check that our algorithm can return the empty list if we give him empty list. Let's save it for now and run. Yes, we get an error. It means that we should write a code. Actually, I prepared some code and it should be removed for a while. Okay. So we create empty variable with list. This piece of code I'll use to debug our code if it will be required. Okay. And now it should return as yes, our tests are passed. Let's make a new test that gives 1 point, so our algorithm should return 1 point. Test 1 point. Sort 1 point. 7, 17. So we expect that our points order is equal to just 0. Just 0 index. List of indexes. Save it and run. Our code failed. So it means that we should write our code. let's make it. So we should take first point. Let it be pivot point. Point is equal to points first. Now, first index, pivot point. Okay, let's run. Wow, as you can see, the second test passed. But wait. Result, okay. Yes. Oh no. Point order. Left contains one more item. Yes, our test empty points is failed. Because we give empty list and it should return empty list. But we also always put first point. So it is the second advantage of our approach that it's easy to modify. We've modified the code and we detected the trouble. So let's change it. If len points is 0, then we should return empty list. And now our tests passed. So the first step of our algorithm is finding a pivot point. The pivot point should be minimum in x-axis, and if there are 2 points in x-axis, we should take the points with minimum y coordinate. So first we should make tests. Def test pick pivot point. Self point scorer. Let's just copy it. And then let's add the second point that has less x coordinate than the first one. -1, 2, 3. So it should return us the points order. First point is a pivot point, so it should be equal the index first. Let's check. And as we can see, we got an error. Yes, because we just return the 0 point. Let's fix it. Main points here, lambda points, and we'd like to sort by x-axis. Let's check it. Assert. Oh yes, because we returned the value itself, but I'd like to get the index. Yes, as you can see, it helps us to make less mistakes. I see mistakes in real time, and I don't need to debug our code. So it is really convenient to develop index point index. Yes, and now our tests passed. Let's make another one test. It actually gives the same test for picking pivot point. Points order, sort point spirally, and let's swap them to Now our pivot point should have 0 index. Let's check this. Yes, it has. And now let's create points that have the same mean axis, mean x coordinate. -2 and -2. And it has 1, and this one has I'd like to break our code, so it should be, if it is 1, I'd like to make it less, so it should be 0, 1, 1, and this is going to be like this. A third point order, so our PowerPoint index should be 2 because it has less y coordinate. Let's check it. Yes, our test is failed. So we should pass it. So let's write a code. Actually, to fix it, we should add p1. So first we sort by x coordinate, and if they have the same x coordinate, they will sort by y. Yes, it is. And let's check the different case. If they are both the same, then it should take the first one. Yeah, it works. So, in this video, we've discussed and practiced a bit test-driven development approach. As you can see, it helps us to define our code behavior, and it allows us to modify our code easily. I hope you find it useful. Thanks for your attention. Bye bye.